Okay, so we're diving into this paper today called Adapting Language-Specific LLMs to a Reasoning Model in One Day via Model Merging an Open Recipe. Quite a title.
Yeah, it is. But basically, it's all about giving LLMs a boost in their reasoning skills, especially for languages that, don't have as much training data as English.
Right, yeah, exactly. So, like, how do we level the playing field a bit?
Yeah, and the really cool thing is that they figured out a way to kind of merge the brains, so to speak, of two different LLMs.
Oh, interesting.
So you have one that's like a logic whiz, but maybe it only speaks English and Chinese, like DeepSeek R1.
Oh, yeah, I've heard of that one.
Yeah, and then you have another one that's, really smooth and, say, Thai, but struggles with those more complex reasoning tasks.
Okay, so like a language specialist.
Exactly, like Typhoon 2. And this paper is about combining the strengths of both.
Ah, that makes sense. So instead of starting from scratch each time you want to add reasoning to a new language, you kind of just adapt what you already have.
Right. It's super clever, and it has huge implications because right now, a lot of those big advancements in reasoning are happening mainly in English. So how do you bridge that gap for other languages? That's what this paper is all about, really.
And it's like the key part of making AI more inclusive too, right? Not just limited to a handful of languages.
Absolutely. And the researchers specifically focused on Thai, using Typhoon 2 as their language-specific model.
Okay, interesting choice. Why Thai?
Well, they wanted to see if they could bring it up to DeepSeek R1's level of reasoning. You know that English one we talked about?
Right, that logic powerhouse.
Exactly. And think about it. If you can do this for Thai, you can potentially do it for so many other languages, right?
Yeah, you're opening up those powerful AI capabilities to a lot more people.
Exactly.
So they didn't start from scratch with a whole new Thai reasoning model.
No, they didn't, which is like the brilliant part, because training a brand new reasoning model for every language, that would be a massive undertaking.
Yeah, it would be incredibly time-consuming and resource-intensive.
It would be. But they found this way to leverage what already exists, with DeepSeek R1, and then adapt it for Thai.
That's really cool. So how do they actually go about doing that? Merging the brains of two AI models sounds pretty complicated.
Oh, it definitely is. But the paper breaks it down into this two-stage process. The first stage is what they call representation alignment.
Representation alignment. Okay, break that down for me. What does that even mean in this context?
So imagine you're trying to get two people who speak totally different languages to understand each other, right?
Right.
Before they can even start translating the words, they need to have some kind of shared understanding of the world.
Like a common ground.
Exactly. So representation alignment is kind of like that for these LLMs. It's about getting them to speak the same language internally, even though they specialize in different things.
Oh, so it's not just about translating words directly. It's about aligning the underlying concepts.
Exactly. It's deeper than just translation. And they do this using a technique called Supervised Fine-Tuning, or SFT for short.
Yeah. Okay, I've heard of SFT, but how do they apply it here?
Well, they use this data set called Bespoke Stratos, which is known for boosting reasoning skills in LLMs.
Okay, so a good starting point for teaching logic.
Yeah, but here's the twist. They translate the questions and solutions in this data set into Thai, but they keep the original English reasoning traces intact.
Wait, so the model is seeing both the Thai and the English reasoning process side by side?
In a way, yeah. It's learning to connect those dots between the Thai words and the logic behind the English reasoning.
So it's like learning to think in two languages at the same time.
Exactly. It's picking up those reasoning patterns from the English traces while simultaneously learning how those same patterns are expressed in Thai.
That's really clever. So they've got the models sort of understanding each other, conceptually at least.
Right. And that leads us to stage 2, which is ability-aware model merging. And this is where it gets really interesting.
Ability-aware model merging. Okay, I'm intrigued. What happens in this stage?
Well, they're not just, smashing those two models together randomly.
Right, because that probably wouldn't work very well.
No, it wouldn't. It's a lot more nuanced than that. They use this technique called DARE. And what DARE allows them to do is to carefully blend the two models, like adjusting how much each model contributes at different layers.
Hold on, they're tweaking things layer by layer. That sounds incredibly complex.
Oh, it definitely is, but it's also incredibly powerful. Think about it this way. The early layers of the merged model are more focused on reasoning, right? So those layers lean heavily on DeepSeek R1's strengths.
Okay, so start with the logic expert.
Right. But as you move toward those later layers, which are more responsible for generating fluent output, the balance shifts more towards Typhoon 2.
So it's kind of like a gradient. where one model gradually fades out as the other one fades in.
Precisely. It's like a delicate dance between the two models
Yeah.
to create something that's greater than the sum of its parts.
I like that analogy. So what were the results of this intricate merging process? Did they actually manage to create a Thai-speaking LLM that could reason like DeepSeek R1?
They did. They called this merged model Typhoon R170B.
Catchy name.
And it achieved a comparable reasoning ability to DeepSeek R1, while importantly, maintaining those strong Thai language skills.
Wow, so they actually achieved what they set out to do.
She did. It's pretty remarkable. And, you're right to be skeptical.
Well, any good research involves testing the limits of an idea, right?
Exactly. So they didn't just stop there.
Of course not. Scientists gotta love them. So what else did they try?
They wanted to see if this approach could be generalized, So they tested it out with another Thai LLM called Celian V370B.
Okay, and drum roll, please. Did it work?
It did. They saw similar promising results, which suggests that this method might be a genuinely adaptable technique for building, smarter and more inclusive LLMs.
That's huge. If this could be applied to any language, we're talking about a major breakthrough in AI.
Absolutely. But it wasn't all smooth sailing.
Really? What kind of challenges did they run into?
Well, even with all this sophisticated merging and tweaking, they hit some snags, particularly with that fine-tuning process.
So getting those models to work together seamlessly wasn't as easy as it sounds.
It rarely is with AI, and this is where the choice of data sets gets really interesting.
Okay, I'm all ears. We know they use bespoke stratos, but what other data did they throw into the mix?
Well, that's a story for part 2.
Oh, come on. You're going to leave me hanging like that.
You'll have to wait and see. It's worth it, I promise.
All right, fine, but I'm holding you to that. We'll be right back after a quick break to unravel the mystery of the dataset cocktail. Stay tuned.
It'll be worth the wait. Welcome back. All right, so before the break, we were just about to dive into the fascinating world of data sets, the fuel that powers these powerful LLMs.
Yeah, I'm really curious to hear what kind of cocktail they came up with to make this merged model work so well. They've got the two models, understand each other on some level.
Yeah.
But how do you actually teach them to reason effectively in Thai?
It's all about the right blend of ingredients, right? Remember they started with that bespoke Stratos dataset?
Correct.
One that's known for boosting reasoning skills?
Right, but that's mainly in English, if I remember correctly.
It is, yeah. So they translated a big chunk of it into Thai. So the model can see, the logic of the English reasoning alongside the Thai expressions.
Right, so the model's getting that dual language view of reasoning. But bespoke Stratos is mostly about those specific reasoning tasks, right? Like math problems and logic puzzles. Did they use anything else to kind of broaden the model's capabilities?
Yeah, they did. Because they knew that to make the model a well-rounded thinker in Thai, it needed more than just those narrow tasks.
Right, you don't want a one-trick pony.
Exactly. So they use this technique called distillation. It's a way to extract knowledge from one model and transfer it to another.
Okay, help me picture this. How do you distill knowledge from an LLM? It's not exactly like making moonshine, right?
Well, think of it like making a really strong tea. You're taking the essence of something larger and condensing it into this concentrated form.
Okay, I can see that.
So what they did was they fed a bunch of general Thai queries to DeepSeek R1, that English reasoning powerhouse.
Yeah, the logic whiz.
Right. And they took DeepSeek's responses and used those to create a new set of training examples for the merged model.
So they're basically showing the merged model, hey, this is how DeepSeek would tackle these Thai questions. Learn from the master.
Exactly. They're distilling DeepSeek's reasoning abilities into something that the Thai model can actually understand and learn from.
That's really smart. So it's like an apprenticeship for the Thai model. Learning from the best.
It kind of is, but there's one more ingredient in their data set mix.
Ooh, what's that?
They also included a set of general instruction tuning examples, both in English and Thai.
So they're adding in some more general knowledge just to round out its education.
Exactly. They want the model to be adaptable and able to handle all sorts of tasks, not just be a specialist in logic puzzles.
Right. It needs to be able to follow instructions and apply those reasoning skills to different situations. So all this data set mixing sounds like a delicate balancing act. How did they figure out the right proportions of each one?
Oh, it was definitely a process of experimentation. They tried different ratios of each data set, kind of tweaking the proportions to see what gave the best results.
So they were like chefs, trying to find the perfect recipe.
Totally. They were constantly adjusting the ingredients until they found that optimal blend.
And what was the winning combo in the end?
Their final dataset mixture was a combination of the original English bespoke Stratos, but a larger portion of bespoke Stratos translated into Thai, plus a good amount of those distilled Thai reasoning examples. They actually found that adding huge amounts of general instruction data didn't really help much.
So it's quality over quantity, even when you're talking about data for AI.
It seems like it. This really highlights a crucial point about LLM development, I think. We're moving beyond just feeding these models massive data sets. What matters just as much is the quality and the diversity and how you put that data together.
It's like a nutrition plan for an AI model.
Yeah.
They need the balanced diet of information.
Yeah, I like that. And that's why this research is so exciting. It's not just about achieving, like, state-of-the-art performance. It's about figuring out how to craft the right learning experience for these models to help them reach their full potential.
That makes a lot of sense. So they've successfully merged these two models, fine-tuned them with this special data blend. But how widely applicable is this technique? Is this just a neat trick for Thai, or could it be used for other languages as well?
That's a great question. And the researchers actually addressed this in their paper.
Oh, good. I was hoping they would.
They believe their approach could be applied to, well, any language, really, as long as you have a language-specific LLM with a similar architecture to the reasoning model.
So you could potentially take DeepSeek R1 and merge it with a French or a Spanish or Swahili. Really, any language LLM.
Exactly. It's that shared architectural foundation that's key. It's what lets the models communicate effectively and learn from each other during that merging process.
It's almost like having a universal translator for AI models.
Yeah, kind of.
That's a pretty powerful concept.
Yeah.
It suggests a future where AI can move between languages smoothly, sharing knowledge and reasoning abilities across those linguistic boundaries.
It really does. We could be talking about building AI systems that are not just multilingual, but also multicultural, able to understand and reason within different cultural contexts.
That's a really exciting thought. This research opens up so many avenues for the future of AI.
Yeah.
But let's bring it back down to earth for a moment.
Okay, sure.
We've been focusing on the positive potential here, but I'm sure there are also challenges and limitations to this approach, right?
Oh, absolutely. No scientific breakthrough is without its caveats, and this research is no exception.
So what are some of those hurdles that researchers still need to overcome with this approach? And what are some potential pitfalls we should be aware of?
Those are great questions, and ones that the researchers themselves are actively exploring. We'll unpack all that when we come back.
So before the break, we were talking about some of the potential hurdles and pitfalls with this whole model merging approach.
Yeah.
What are some of the things that researchers still need to figure out?
Well, one of the big ones is that this method still relies on having those separate language-specific LLMs for each language you want to target. Those base models still need to be trained, and that takes, a lot of data.
So the data scarcity issue, especially for those less resource languages, isn't totally solved.
Yeah, not entirely. But this research does give us a more efficient path forward. Instead of training a whole new reasoning model for each language from scratch, we can maybe use this merging technique to adapt what we already have, like DeepSeek R1.
Right, so it's about working smarter, not harder.
Exactly. It's about making the most of the resources that we have. But there's another challenge I think is worth thinking about.
Okay, listening.
So this research focused on, injecting reasoning abilities into those language-specific models. But what about going the other way?
Oh, interesting. You mean like taking a reasoning-focused model like DeepSeek R1 and making it more fluent in other languages?
Exactly. Could we use this technique to boost the language fluency of a model that's already great at reasoning?
So could we turn DeepSeek R1 into, like, a polyglot?
Maybe. It's a fascinating idea, and I'm sure researchers are looking into it. But it would definitely come with its own set of challenges, making sure that model can keep its reasoning abilities while seamlessly switching between languages. That's a pretty tall order.
It's like trying to create a super brain that can think logically and speak every language at the same time.
It kind of is. It's a huge challenge, but the potential payoff is huge, too.
Imagine AI that can truly bridge those cultural and linguistic divides. It could change how we communicate and understand each other on a global scale.
It's a vision of AI that's not just powerful, but also, profoundly human-centric.
I love that. Well, this has been a really insightful deep dive. We've covered a lot of ground, from the nitty-gritty of how this model merging technique works to its potential applications and the challenges that still lie ahead.
It's been great unpacking all this with you.
Hey, for our listeners who want to learn even more, we've got a link to the full paper in the show notes.
And as always, don't forget to subscribe and hit that notification bell so you don't miss out on our future deep dives. We've got plenty more exciting research to explore.
Until next time, keep learning.
Yep.
Keep asking those big questions. And remember, there's always more to discover in the world of AI.
Absolutely. There's a whole universe of knowledge out there waiting to be explored.